Okay, so good morning. Welcome to session 2. Today, we are going to work on mostly cluster system and scheduler. But before I get into that, let's go and talk a little bit about the first session and about the homework. Actually, I want to tell you a couple of things there. So when you get the tree in the homework, so let me share my screen first. Okay. So I guess you can see the screen now. So your homework was trying to create this tree structure in RNA-seq directory. So this wasn't a bootcamp directory. This was an RNA-seq directory, different directory. So if you finished all the bootcamp tutorial, you could have created a new directory like RNA-seq, and then you could create other directories here, like 3 more directories like MM10, procs, and reads. So these were directories, folders, okay? And when you see such thing like this, it means this is a link. Usually what we do, like if the file is big, like genome file, we usually create a link for it. We don't want to move those big files everywhere. And if we need that, that file in a specific directory, we just create a link from there. And when you see this, some of you guys, when you were doing your homework, you copied this file there too. It increased the size of your zip file. So don't copy it here. So when you do the tree, if you don't see this arrow and showing this file, it means that you copied that file. So don't copy there here. I would just wanted you to learn like how you can create a link, how you can get this file, UCSC-GTF file, copy from this directory to your own directory into MM10 here. I just wanted you to learn copying from your target location to your, source location to the target location. So this is what you did. Basically what you did was this. Many of you guys already did so, but I just want to go over, like you just write like CP, and this, you copy this one, space, and you just to put like tilde RNA-seq slash there, dot or whatever, like just slash would be enough. And the file would come there. So for this one, you go back with like cd dot dot and cd procs. You came into this directory and get this file using wget command from a URL. So this is also important. In the future, you might see some files on the internet. You might want to download them. You're going to use that command. This is also something I wanted you to learn. And the last thing here was this was like all FASTQ files. These are the suffix of these files were FQ. So I want you to copy them into your reads directory. Sometimes you want to get your backups into other directories in your nearline. We're going to talk about this kind of storage in our cluster today. So I wanted you to learn how to get a backup to somewhere else, because in our system, when you use project space or nearline space, there are no backups there. So you have to take care of your own backups. Either you can do this on your own like laptop, or use an external hard drive, or use another directory, because when you delete them in our cluster, they're gone. So make sure you get the backups for all the files you need in the future. Okay, so this was the homework. And the one more thing that I saw one of you guys did. So that person didn't use Z option when zipping the file, when packing the files. When you use the Z option, it is just zipping the file, and it will use less space. And let me show, the size should be the size should be this, like 4.907.172. So the size should be around this, and it's around like 4.7 when you do ls minus lh. So it's going to be like 4.7 megabytes or something. So if you could do this, you're good. Okay, so, and if you have other questions, we can talk them later. Okay, so let's go to session 2 now. So how we're going to do here every week or every session, before every session, we're going to put links here. And then you can click those links. So you can put this into your bookmarks or somewhere to access faster. So, and I will put all the other sessions. We're going to have like 9 sessions here. And I will try to cut the videos that I record today and share with you guys in here too later. But I couldn't cut yesterday all that video. I just shared the whole thing. So hope it helped for some of you guys. But I'll work on that. So okay, today I just clicked the session 2, UMass High Performance Computing Center and Cluster. We're going to talk today. So, and basically what Cluster is doing is like what you're doing in the bench. So basically it's like, think about this like a pipette, like you have multiple channels here. Basically you're like using this, maybe, I don't know how many channels here, like maybe 10. So you can just get this 10 all together and put them all together into these tubes here or wells. So we are doing same thing. When we want to run, for example, 10 samples at a time, or imagine you have 100 samples, when you run those things from command line, you have to usually submit them one by one. So it takes a lot of time if you use only your computer, or only a single machine, means that you need to run them serially. But what Cluster is doing, Cluster includes lots of nodes. Maybe I can show you this. Lots of nodes. In our cluster, we have like more than 10,000 nodes. And what you did before last week was you just connected to the head node. Okay, so, and what we did there was that we copied the files. That's all fine. You can do those kind of things on the head node. But when you want to run a real command, like, aligning the reads to a genome, it's going to take time, like maybe, I don't know, a couple hours. If you want to quantify those, your reads on a transcriptome or genome, it's going to take maybe 8 hours, maybe a day sometimes, if your data is big. Or when you're running a single cell RNA-seq data analysis, for example, sometimes it takes a week just to run. So you cannot run those things on the head node, because head node is shared to everybody. So all users are going to connect to the head node to submit the jobs to this job scheduler, and job scheduler is going to dispatch all those jobs to these nodes, and your samples are going to be processed parallel in this environment. And it's going to be, this environment is like a fair share environment. So I'm going to talk about that in details, that how it is measuring what is fair for all the users, which one is going to start first or later. So I'm going to talk about this today. By the way, when I'm talking anything here, if anything is not clear, please ask that question here, because these are important things that when you use Cluster, you have to understand what we are talking here. And if you have like other questions, please ask today. We can do more interactive. So first, I want to talk about the storage organization. So in the cluster, you have your cluster here, and we have a couple storage mounted in all nodes and the head node too. So, and those storage you see here, one is your home space, and it's limited. So your home space that we use with tilde here, we usually use that space for like some scripts we write, small scripts, some small files, because it's limited to 50 gigabytes. So you cannot increase that. And don't use this place to process your like real RNA-seq data or real any data you have. It means that they might take a lot of space. When you want to process the data, maybe it's not going to be enough, using this space. So what we have here, we have two different space storage mounted all nodes and the cluster head node. So one is project space. So every PI has 2 terabytes of space here. It's going to be free for your PI. So, but it's again like shared space for the lab members for that PI. So if you need more space in your project, you need to send an email to HPCC admins, and they might increase this. They will increase this because we have big storage there. But the problem here about project is it's more expensive than nearline system. So usually what I do, I use like 2-3 terabytes on project, like 15-20 terabytes according to my usage. I use that much space on nearline. This is cheaper. And especially if you want to get like short-term backups, you can use this nearline space. But again, any of these spaces here are not good for backups if you have a lot of files, because they don't back up your files into another place on nearline or project. So if something happens, even to those backups, you cannot get them back. So what we are doing, like, you know, in our labs here, especially Özkan like talked last week, and he created a new backup system. What he's doing in PMM is he's getting these backups to Amazon. So what he is doing, like, you know, you put your files to project or NL space, nearline space, and running one pipeline on Dolphin Next. We're going to talk about this in following weeks. But what he is doing is like he puts those files onto Amazon, and Amazon is not that expensive to keep the files, or much cheaper than nearline or project space. That's why we use Amazon for our backups. The only thing is it's nearly the same price if you want to download the files from Amazon. So you don't pay anything Amazon about while uploading the files, but you're paying while downloading. So that's why we use for backup purposes. And we don't like download all the files all the time. What we are doing, basically, we are just like downloading if any file is corrupted. This happened before in last 10 years, a couple of times. But if the data is extremely important, we can help you to upload your files to Amazon and, you know, give you some estimates that, you know, how much the costs about those backups. Okay, just talk with us. Or Özkan is doing these things for PMM. You can learn from him too. Okay, so today I'm going to talk about like this head node and why we need nodes. Again, so I'm just going to connect the cluster and show you some differences. So you can use like this AK. This is my user, PHPCC06 umassrc.org. So when you connect to the cluster, you already see this GHPCC06 from here. Or, you know, when you are in another directory, maybe you're not going to see this here, or maybe it's not there. You can always use host name to see which machine you are working on. So again, I want you to be careful when you are using here, because, for example, there are some programs written in Java or some other programs that if they require a lot of memory, you cannot even run them here on the head node. They have a cap there, memory cap. It's going to kill your job there. So usually we don't use head node to large operations or large data processing. What we do here is only copying the files, basically. Or sometimes we use a couple of useful commands that I'm going to show you today to check if the file is right, or do some other stuff here, but not like doing actual data processing. Okay, head node is mostly for connecting there and then launching jobs on the nodes. Okay, I'm going to talk about those. So how we're launching the jobs. So there is another software, another application called job schedulers. There are many of those. In the future, when you go to another institute, another company, maybe you're going to see that there are many different types of job schedulers. Here, we are using in MGHPCC. This is like green, Massachusetts Green High Performance Computing Center, MGHPCC. When you see that word, you can like that means this. So in here, in our cluster, what we are using is LSF. And this is one of the applications that will allow us to submit jobs to the cluster and run them parallel in a fair share way. So for example, here, what we're going to do today, we're going to run start. And imagine you have 100 samples. You cannot run them one by one. What you're doing is you're going to run 100 jobs. You're going to submit 100 jobs. They are all going to run parallel if cluster is not busy. So if cluster is busy, sometimes they are not all going to run parallel, but you know, they're going to wait other people, and then eventually they're going to be dispatched. So we use this dispatch word there when the job scheduler starts the job on one of the nodes. It's just asking one node to LSF, and LSF arranges a node to you to run star program on that node. And when it's done, it's just release that node and give that node to somebody else, and or maybe you again for another star run if the cluster is busy. Sometimes it takes time. So another thing we do, like, you know, in the future, if you have a budget or when our cluster is not enough anymore, because, you know, our cluster has only 10,000 nodes, and sometimes it gets really busy and you cannot do anything there. What we are doing those times, if we need the data like real fast, we utilize Amazon resources. So we are starting another cluster on Amazon, and we are paying them for the data processing and processing data there, and get the results sometimes much faster. Sometimes you want to get the results like in 2 hours, 4 hours, if you are in a hurry. If you're writing a grant, for example, sometimes you're going to need these things. But we simplify those things in Dolphin Next. We're going to show later in a couple of weeks. But most of the time I'm using cluster because it's free. Running the things on the cluster is free. So I want you to do these things together with me. So what we're going to do now, we are going to submit the first job. It's going to be like, you know, when we run this echo hello LSF, for example, I'm just going to run this like this. See what it did? It just write this hello LSF thing here. Echo is like printing command to whatever you write here, echo anything to the screen. Okay, but this could be anything, like any command you want to run. Start command will be like this, and then there'll be space and some parameters we're going to write, and then run the start, and we're going to attach your files. So I want you to look at this thing like that. You know, it's basically you're just communicating with the machine there using these commands, and echo is one of them. So this is just to show how we are submitting jobs. In this case, you learned this last week. We're going to put this echo LSF, whatever we write, into this file in your home directory. That'll be a first job.txt file. So let me run this first, just to show you what I'm going to expect. So in my home, I have many files, but I don't have that first job.txt. Oh, I have. I'm going to remove that. Okay, so I don't have it now. Okay, F, and I press tab button, so it's not showing it. So what I'm going to do now, I'm just going to do this. So when I run any command, if I want to put the output of this command, not to the screen, but to this file, into this file, what I do, I just use this symbol and the file name on my home. This could be in another place, in your project space, NL space, wherever. You just need to write, like if I was going to put this into my project space, I would do like this: project BMW biocore and first job.txt. So let me do that. And when I look at here inside of this file with more, see, I see this inside. So this is important. Like sometimes you just want to run something on the cluster and you want to track the result of that run and put the standard output. We call this a standard output into a file. And this is how you do it. So in this case, I just did this in 2 different locations, and one of them was here. Let me show the first one. Okay, they're both there, and it run. But again, this run on the head node. Okay, this didn't run on your one of the nodes. So again, like when we want to run a big run, we are not gonna run them in the head node. So we're gonna submit the job. So how we're gonna do it? Let me delete them again. And now this time I'm gonna run on the cluster, on the one of those nodes. I just delete it. It's not there. So how we're gonna do this? There's a command called bsap. It's like another command, but all the commands that I want to run on that head node, one of those nodes that I was talking about here. See, we are on the head node now, and we are going to use the job scheduler using bsap command to submit the jobs to the nodes. One of the nodes. It's just going to give us a node that I'll show you how we can actually track that job later. Okay, where are we? Here. I'm just going to run this command for what is happening. There's a clear command. If you want to just clear your screen, you can use. And I will just run this. Okay. Okay. Now, there's another command like bjobs. It's down there. I will talk about details, but it gave me lots of warnings here, and I'm going to talk about what they are later. And then it just gave me a number, job ID. So I can track this job with this ID, and it's submitted to the queue. There are a couple of queues that I'll talk about, short queue, long queue, that I will talk about them. But when we submit this job, when I say bjobs, it's finished. There's no unfinished job. But if you want to see all the jobs that I ran, see this job, first job takes the job is submitted. See, it's submitted from this, from my head node, GHPC06, and this when you see this kind of C39 something like a C01, these are the nodes that I was talking about. So it's going to, like, some part of that node will belong to you to execute your job in that specific node. Okay, and the host name, like if you can go to that, I'll show you how. But if you go to that specific host, and when you write host name, it will give you this name, not this name anymore, because it's a different machine. Basically, what cluster is doing, it's unifying like 10,000 different machines into a single machine, and it unifies all of them and gives you, like, simplifies running the jobs on a single supercomputer. We call these like supercomputers. All the clusters, supercomputer, means that you just access to one node, and that node will give you access to 10,000 other nodes. And this one node is called head node. Okay, so now if the job is done, you see the status of that job done. But sometimes, as you can see here, some of my jobs became zombie, means that this host lost connection with the job scheduler that we are using, LSF job scheduler, for example. And when it lost the connection, your job becomes zombie, and sometimes they work, sometimes they fail. Something happened to this machine there on the cluster, and it just couldn't finish the job. So when you see such things, zombie, or you see status unknown, or sometimes you see the status error. So anything you see such thing, if it is not done, it means that you need to rerun that specific job. So you need to follow up everything, all the jobs you run in the cluster, and make sure that they finish successfully to move forward. Because usually when you do RNA-seq run, you're going to see tomorrow, next week, that you're going to do lots of runs, and you have to follow up every single job you run. Otherwise, one run will finish, one sample finish successfully, the other won't, and you want to just unify them in a single table, then you're going to have a missing samples. So you don't want to do that. You just want to follow up. every single job, and you can organize them in the files. You can put these things and some of the results into files like this. For example, if I do this, bjobs -a to a.txt file, I'll see I have this in this file. So you can follow up these kind of things. And when you see if one of the job is has an error, you need to see what job is that. I'm going to show you how you can actually change the name here, give a like more meaningful name that will remind you what that job was, and then you can rerun that job. Any questions till here? Please, you can. I can go like forever like this, but I want you to hear anything that if you haven't understand anything. And here, don't be shy too, please. There is no dumb question here, especially when you're a beginner. You can ask any questions, and don't hesitate asking those questions, because some other people might have the same question, and you're going to help other people too. If you have any question, it will help us to understand like how you're getting these things we are telling. You can cut me off. Okay, so there are a couple more things here I was going to tell you about nearline space. So there is a speed difference here in project space and nearline space. Project space is a little bit faster than nearline space. That's why it's more expensive if you want to get more space. But on average, you know, if you're not in a hurry running anything, just get more nearline space. There are more space, like the size of the whole storage is larger than project, and you can still use nearline space. For many operations, you're not gonna see the difference. So I suggest getting nearline. Again, if you need more space, you can always send email to HPCC support, increase your space, process your data, and then when it's finished, you can decrease the space. So you can utilize the storage like this by communicating with HPCC support people. They are very, very fast, so they are very good in this. So now I want to talk about these warnings a little bit. So what we did when we were submitting the job, we just used bsap command, but we didn't tell that specific job how much memory we are going to use, how many CPU or nodes in a, like how many cores in a node we want to use. So one more thing I was going to tell you here in the nodes, we usually have like 8 cores. Like in your laptop, I don't know what kind of laptop you're using, but sometimes you have 8 nodes, sometimes 16 cores, sometimes 4 cores. Means there are 4 different like hardware that will do the operation simultaneously. So you're going to do parallel jobs. If you have 4 cores, you can do on average like 3 to 4 parallel jobs in that specific machine. So in these nodes, if you just require single node, you can do like 8 parallel jobs, for example, if you want to use 1 core per job. But you're going to see a couple of usage. For example, when we use star, we utilize 4 cores for 1 sample at the same time. So it just decreased the time of alignment around 3 to 4 times. So you run just 1 sample, process data parallel using 4 different core on 1 node. So this will help sometimes finishing jobs much faster. Okay, this is also important to know, like 1 node doesn't mean that you're going to do 1 operation on that node. You can do many operations as long as you have enough CPU or core. I sometimes use CPU, sometimes core for that thing. But today, one CPU might have multiple cores. So when I say CPU, don't get me wrong. What I mean when I say CPU, usually core, okay? Means in 1 CPU, for example, you have 8 cores, you can do 8 parallel runs on that CPU, on that node. So what does that mean? Like, for example, if you're doing a little operation, small operation, like you want to just do the quality checks, you don't need to run them parallel because it's going to finish fast already. Maybe it's going to take, if you have like 10 million reads in your file, And just to check the QCs and run fastqc command, you're going to learn next week. So just to run that command will take 10 minutes. So you don't need multiple cores for that. You know what you do, basically, you just need one core and run it on one node. So what does that mean is when you submit one job like that on one node, that means other people can utilize the same node. So this is important here because you have to be respectful to other people around you. For example, if you are, when you run the bsub command, we're going to learn how you submit the jobs to and ask like how, the memory and the number of cores, the processing units you want to use, and maximum amount of time you need to accomplish your job, and which queue you want to run. So there are a couple of things you need to know here. We have like, we use usually 3 queues here. One of them is interactive queue, means that you're not using head node, and I'm going to show how we are doing it. You just request one interactive node. You go to that node to use that for up to 4 hours. Means that you can do all the operations on that interactive node, but not on the head node. Even if you want to try, for example, larger memory that requires to run fastqc, for example, or anything you want, you cannot run those things on the head node. That's why you're going to require interactive node, that I will show you how we're going to get it. And short and long queues are not interactive. So when you submit, you cannot connect them. You just wait until that they finish the job, and then you're going to check the output, standard output, or you're going to do the B jobs just to check the status. If it is finished, you will see the output files to see that if it is finished successfully or not. So here, what you can do when you are submitting the job using bsub command, you can define the queue, you can define the time limit, but you can ask like this kind of question: how would I know how much time will it take to finish that job? So this is like trial and errors. Eventually you're gonna get this. You can ask us, like, for example, if I have 10 million reads in my file, how much time will it take? And to run one specific program like star, for example, I'll tell you it's going to take 2 hours. So you're going to ask 3 hours or 4 hours time, if it is like that. Or sometimes if you are working on, like if you're running fastqc, again, like if you have 10 million reads, it's going to take 10 minutes, sometimes 5 minutes. The other thing about these cores and nodes they're not all exactly the same. Some of them are stronger, newer, some of them are old. In some nodes, it's going to finish in 10 minutes. In some nodes, it's going to 10 and 20 minutes. Excuse me, any question?
I could give you a couple of microseconds.
Well, won't take that long.
Can you silence them?
So final writing this paper.
Sorry, excuse me. I hear like, is there a question or? Okay. I guess there's no question. Okay, so I'll continue here. So when you are submitting the job, you're gonna define how much core you're gonna need, how much memory you're gonna need, how much time you're gonna need, and which queue you should choose. So according to that run, you can define all those things. After you have enough experience, you will already know how much memory or time or cores you're gonna need. If you don't know that, you can ask us. At the beginning, we can tell you more or less what you need, and then you're gonna run them successfully. If you try running and it failed, and it will tell you why it failed. And I'll give examples that. For example, you ask less memory. For example, the program you're using requires 16 gigabytes of memory, but you ask 1 gigabyte. And it will tell you, hey, the memory is not enough, increase it. And then you can increase. What I do usually, if I get an error, I double the memory, and it works. And or sometimes it's gonna fail because of time limit, and then you're gonna double the time limit, or I don't know, like more or less increase the time limit. Usually cores, I'm gonna tell you what it is, but what I do here when I'm running anything, again, I told you, you need to be respectful of other people, because some of those limits that you ask, are not hard limits. So for example, you submit a job and ask one core, and the program you're running, like Star, you can tell the Star to use 4 cores. So it will do that, but you're going to utilize extra cores there that might be used by other people, and it might crash their runs or your run will crash. So that's why respect is important here. So how many nodes you ask or how many cores you ask is important here. Then please try to use less cores than the number of cores you ask, or exact amount. Like, if you ask 1 core, please use the 1 core. If you ask 4, please use 4 or 3 less. And for the memory, it's the same. Especially this is so dangerous because these machines have like a limited memory. Okay, for example, one node has 512 gigabytes of memory, and some of the tools are using, like HiSet2, for example, and a liner using a lot of memory. If you are running like eight samples on one node, and each sample might require like 64 gigabytes of memory, and when you multiply, if it's more than like that, the total memory that you have on that machine, it means that if you run them like parallel, some of them might crash. So you have to be careful. You shouldn't like go over the memory. There are lots of things that doesn't like allow this. There are other controls, but sometimes you ask like 32 gigabytes of memory, but that program is using larger memory, and this is kind of hard limit. It's going to crash your run, and it's not going to continue. Okay, so once you start using this a lot, you're going to understand like what parameters you choose while submitting your job. Again, this is like kind of hard way to process your data, but we have in Dolphin Next, you're going to see all these defaults already set there. So we have an advanced tab. You can see for each job you want to start or run, there are some defaults. So you can learn from there in the future. Like in a couple of weeks, you're going to start learning Dolphin Next. You can learn our defaults and then run with those defaults first. And then later, if you need more, you can increase or decrease. But why these are important? Like why I need to define these. So I'm going to talk about it now. So this is the scenario that I'm going to talk about. Like this is the job scheduler is doing this node distribution in a fair share sense. So what does it mean? So we have, for example, 3 users, Hakan, Onur, and Artur, and they submit a job to the cluster. And in the cluster, we have a queue. At the same time, there can be many people. Let me show, for example, what I mean. So there's a command in the cluster called bq. bqs. See, these are the queues that you see. Some of the queues are not belong to us, like for example, administrative queue. This is, by the way, not only for UMass Medical School. These are belong to all UMass. So some of them are maybe, some people are from UMass Boston or like or Amherst. See, they created their own queues here because most likely these machines belong to them, and they created their own queues. In the future, if you create your own class and put in there, you might have your own priority queue. See, there is like one column here called priority. It means that if you belong to this lab, and if this cluster is belong to you, when you submit the job into this queue, you can define, I'm going to show how, but you can define this queue, and you're going to have a higher priority to get because you belong to that group. They are doing this kind of fair share. In our case, what we are using, we use long queue, short queue, and interactive queue. And some people are, doing like image operations, like, they are using some AI algorithms to check things on the images. They use GPU queue, and But what does these priorities mean here? So, for example, when you want to get an interactive queue, I'm going to talk in a second what it is. So when you want to get an interactive queue, most likely when you ask for it, the chance that you get it fast is really, really high than anything else, because this queue's priority is really high. Okay, so but there are some limitations here. And for example, in this case, you see how many jobs, how many interactive nodes are running here. So see 7. So in this case, for example, short, there are like 512 short queues, maximum 2000, but this 64 run is on that short queue. So, but the limitations means in interactive queue, higher priority. If you submit a job there in 4 hours, you have to finish your job. Otherwise, they're gonna kill it, you know. So, but interactively, you're running there. Even you don't exit there in 4 hours, they're gonna kill the job. You're gonna exit from that interactive queue. If this short queue is the same, but this is not interactive version, and there are like maximum 2000 nodes allocated to short queue, and when you want to do something fast, it's less than 240 40 minutes, maximum 240 minutes. So you can define how many minutes you can use. So if you are submitting a job larger than 240 minutes, you need to submit them to long queue. Short queue for short operations. There are many short things that we are doing, so you're going to see. And for those, again, the priority is higher. And if you want to finish them fast, if it's a short job, you don't want to submit them to long queue, okay? Because it's going to wait here more. Again, but the problem here, if you see, when you do BQs, if you see 2,000 people are using here, then you don't want to submit them to short queue. If there are less people using long queue, because long queue, see, there's no max here, means that it can utilize all cluster nodes. There are more than 10,000. For interactive, it's the same. It can utilize all 10,000. When you need it, you're going to get it. It's very high priority. So how I'm doing it, I'll give you the example, and then I will show you how we are getting the interactive queue. So please, if you don't understand what I'm talking about these kind of things, priorities, please ask me. These kind of things are important because sometimes you want to finish your job faster and you submit the jobs to long queue. See, there are 6,000 jobs are already running there. There are 2,000 jobs are pending in your long queue. It means that if you submit anything to your long queue now, you're going to wait. I don't know how much time, but these people are waiting here. But here, most likely, see, only one job is pending, not many. So, in these kind of cases, you might think that, okay, why don't I do the short jobs first and then maybe wait at night, or you can still submit them, by the way, but it means that you're not gonna, your jobs are not gonna dispatch fast here because these people are waiting. And the total number of jobs are like this many. Okay, I want you to be aware of this BQs. When you just run this, you can look at there and then decide which long or short queue you want to use. But this doesn't mean that you're going to wait a lot, okay? So this means maybe, in a day, they're going to all finish. Usually, even long queue, they don't run too much. Unless, some people are coming here and they're doing some operations. One job takes a week and they submit 10,000 jobs. Sometimes I see here 30,000, 60,000 jobs pending. If your job wait is longer, or if you ask too much memory or too many cores, your job will wait more. Okay, it's this scheduler that I'm going to talk now is doing this kind of fair share. If you ask less resources, most likely your job will be dispatched faster. And if you ask more resources, your job will be dispatched slower. That's why I want you to understand queue definitions. I want you to understand memory and core, and I want you to optimize all these parameters to allow this, to allow the scheduler to dispatch your job fast. So in this example, these guys came in, Arthur, Onur, and Hakan. And first, Hakan submitted the job, later Onur, and after that, Arthur. And in the queue, they're gonna come into the queue like in this order, okay? Imagine like, if you think that, okay, first come, first serve, if it would be like this, you would think that Hakan's job will start or dispatch first, and this job would start in the cluster first, but it's not the case, okay? Imagine, in this case, Hakan needs 10 cores, okay? A lot of cores, and 5 terabyte of memory. This is just exaggerated. We never need this much memory, but this is exaggerated just to tell you that you need lots of memory, and this 10 cores will run 8 hours, okay? And Onur, the second, he came second to the queue, and he needed only 2 cores and 8 gigabyte of memory. And this 2 cores will finish the job in 1 hour. And Arthur came in, and he only asked 1 gigabyte of memory and just 20 minutes. So what it is doing, it's just giving some priority scores to these jobs by looking all this resource usage, and it gives you some numbers like 540 and 110. See, Arthur get the highest score, even he came last, because he optimized his runs, and his job will be dispatched fast. He's gonna wait less, okay? Because he knows what he's doing, and system actually gives a faster response or faster dispatching time for Arthur runs. And another thing that you need to think is also, if Arthur is not using cluster too much, this score will be higher. If like Hakan is using like cluster all the time, like, it's just, but this scores will be, it's going to reset these scores every 3 days. So if you don't use the cluster 3 days, this is not going to affect. But if you are using the cluster last 3 days a lot, this score will be lower and lower. So it's trying to create like a fair share queue for everybody. If you are just like a rare user, then even you ask like more resources, your score will be higher. But these scores, you're not going to see these scores, anywhere, by the way. This thing that these are like kind of imaginary scores. We believe that these are working fine. I never seen any problem. We were seeing these problems before, but our cluster people, we discuss these kind of things with them, and they create a very fair share environment. And now when we run anything on our cluster, usually I feel like they dispatch pretty fast. But again, I want you to understand this priority queue definitions, and understand like how much memory you are going to need to run those things, and how much CPU or core you need, and then optimize your runs according to your need. Okay, how we are doing it, how we are asking the number of cores, the memory, and time, and also queue. See, they are all here. So in this case, for example, I'm going to run like this minus N1 means I ask 1 core. And in this case, memory, our usage, it's just, you're just going to do like this. Just if you need more memory, you're going to change here. So in this case, I'm asking 1 gigabyte of memory. And this W20, it means 20 minutes. And if it's 20 minutes, it should go to short queue, because we know that short queue priority is higher. Most likely it's going to dispatch there faster, and this will finish there faster. I all want you to do this and see like, these many people will come in and they're going to submit the same job, and this sleep 300, by the way, is going to just sleep. It's not going to do anything. It's not going to use any CPU, nothing, but it's going to just sleep. Let me run it here just to show you what it is doing. It's just waiting 300 seconds, by the way. Sometimes we do this to show that this is running now. I just exit with Control-C. I don't want to wait 300 seconds. So what I'm going to do now, I'll submit this job and show See, now I just get one warning. This is not important. It's about the Node OS version. You can select it too by adding this extra parameter, like this whole thing here. This means that Red Hat 6, you can define which Red Hat you want to use. I told you, like, the nodes are not exactly the same. Some of them are using a different Red Hat version. Sometimes you might need a specific Red Hat, means like, some specific version of the Linux, then you can use this. But when you see a warning like this, you can ignore it, okay? I ignore now, and I'm just gonna show it like when it is running. When I do bjobs, see it's running. Most likely yours are running too, okay? And this will run, and you're gonna see, this is the job name. I didn't change the job name, but you can give a name. I'll show you. And this submission time here, you can track down here and then see what's happening. So if you want to see more details here about this specific job, you can get this -L option here, -L, and put the job ID next to it. Oops, sorry. My mistake. I couldn't copy. So I'm just going to copy here and show you what you see here. See, I just run this bjobs -L, the job ID. So sometimes you do this when you have multiple jobs. You want to see some details about which job you submit, what it is doing, which directory I started submitting that job, or how much CPU, how much time I asked, and where it ran. Sometimes you get an error here. You don't understand the error. It says that it's killed, and it doesn't tell you the reason. And if you want to ask these questions to the HPCC admins, or if you want to get support from them, you say that, hey, I run this on that machine and I couldn't access my files on that machine. And they're checking, they're telling you that, hey, there was a problem on that machine and it couldn't mount your storage there. That's why you couldn't access. So we remove that machine from the cluster. You can resubmit. They're helping you like that. So you can get this kind of information here. And resource usage, see how much memory you ask, or these kind of things you can get here. And where is that? Sorry. It's these are some scheduling parameters, like those like priority scores that you can get here. And in this case, maximum memory. See how you can learn your like your star or your command used. So you can get the maximum memory usage here. Okay, you can learn next time. For example, you run star once, you had 10 million reads, and you asked, I don't know, 64 gigabytes, and you realize that that star algorithm running 10 million reads only used 10 gigabytes. Then next time you can ask 15 gigabytes. You can start large first, run it, learn, and then write them down or create your own notes, and then you can utilize that information in your next run. So this is how we started learning these things. And sometimes they add new machines, they run faster. Just don't rely on exact numbers here. Don't write, for example, 10 megabytes. Don't be like that close to these numbers. Just give double, or a little bit, like double is fine. Usually I do double because some machines are slower, or when they are slower, usually I ask more time. So just make sure you have enough time, because sometimes you run a job and it takes like, I don't know, 8 hours, and you ask like 7 hours. So when it fails, you cry because you wait that 7 hours, and then it failed, and then you run again and another 8 hours. So that's why just give a little bit more. That's your priority score will not change too much if you ask, I don't know, 8 hours versus 12 hours. But it's going to change if you ask, like, if you're going to run that within like 8 hours, but you ask 1 week. So don't do that. Okay, just be aware of these kind of parameters. But sometimes, for example, when you're running single cell, so it takes like a week, you need to ask that a week. Otherwise, again, like in that week, if it finishes on like 8 days, then again you cry. because you need to start from scratch. So there are some runs like that. Okay, I think we started good, and it's 10 now. I want to take a, I don't know, maybe 10 minutes break, and I'm going to be here. I can answer your questions, and then we're going to start like 10:10. Go into more details about other things. Okay, now we can discuss if you have any questions.
So far, so good. Thank you.
So what's happening? You know, I remember our other bootcamp classes before. So when you spend enough time on these things, you learn good enough to be a bioinformatician. You know, I know some band scientists became a bioinformatician later. I suggest you to learn, especially in the future, you know, when you are doing your bench work and do your own analysis, is going to be speed up your, you know, analysis much faster. Otherwise, wherever you go, you're going to wait a bioinformatician if you don't learn these things yourself. This will give you a lot of power in the future if you know what you're doing on these cluster systems. And, you know, if you spend enough time, it's not that hard. You
So
can
to become a bioinformatician, what else we will need than this bootcamp?
Yeah, you need to learn like a programming language real good, and a couple of more analysis like interpreters. Like, for example, you can learn a language, I don't know, like a Python. That will be like, if you want to be a real bioinformatician, means like, you know, a person who can write programs when needed. But I see lots of bioinformaticians now, they don't even write programs. So they're running existing programs. They learn these cluster systems, Amazon, those kind of things real good. Usually they use third-party programs. What they learn is they are learning, for example, R or Jupyter notebooks to do these kind of analysis on Jupyter. Jupyter notebooks is based on Python. So you need to learn a little bit Python there to be able to do the analysis, plots and everything. But I suggest you to, if you want to start learning these things, I would start learning first R and Python. And if you want to go one more step forward, lots of software written in Perl. So you can learn Perl too. And it helps a lot us learning Perl. And if you want to be like an expert bioinformatician, then you can learn other languages like Java or Scala, Groovy, you know, these kind of languages. Yeah, this is the path.
So learning R is a good starting point, right?
R is the perfect starting point. Even you're not a bioinformatician, if you want to create your own plots for your publications, if you want to play with the colors, if you want to, like, we're going to learn R here too, but I would invest a lot of time on R. If I was a band scientist, if I were a band scientist, I would spend a lot of time learning it, because they help you a lot in the future to organize your papers, to create better publications. Otherwise, you know, like bioinformaticians are make you wait like a month for a plot. So I don't know, like not all of them are like that, but you know, this is the experience that I heard a lot from people.
Right.
Okay, I'm gonna get a coffee and be back. Okay, let's start again. Anything you want to tell? So I'll start. So now let's go back and submit a couple of more jobs. And I want to show you a couple of more things about the monitoring your jobs. Okay, so let me share my screen again. Okay. Oops. Here. Let's do this monitoring jobs. So again, this B jobs command will show you all the jobs. Let's submit a couple of jobs now and get a list like this. I want you to do that too. When you are following me, you can run a couple of jobs. So I'm not going to define all these things. It's up to you. You can just run this a couple times, 2-3 times. I'm just going to submit like this. Oops. Where was my, okay, here. So one person asked like how I clear my screen. Just type clear into your terminal like this, and then it will clear. I'm still on the head node. And what I'm going to do, I'll submit this job. Another one, maybe another one. It's going to wait 600, okay, seconds. Means 10 minutes. See, they're coming. So some of them are running. The third one came running. See, 2 of them are running on the same node. See, you see exactly the same host name here. And this is going to run 600 seconds. They're not going to do anything. And when you look like B jobs minus L, if you don't write anything here, any job number, okay, it will just show all your jobs. So you can, so it's going to separate them with this, and all your jobs will be listed, all the information about your jobs with B jobs minus L, like it will list all the information. So, and you can see like what they're going to do here. So when you don't use any of the parameters that I showed you, like if you submit B sub with B sub without any parameters, it's going to use the defaults like 60 minutes, for example, for CPU limit, and 1 gigabyte of memory limit. See, it's here, your memory limit, and it will be in your short queue. Okay, if you don't do anything. So those are going to be your default parameters. If you want to change them, you can change it with these things, WD. So again, this is 1024. Why it's not 1000? Because, you know, when you convert bit to the byte, byte to the kilobyte, kilobyte to the megabyte, there are like some little bytes there, makes it like this. If you just want to see 1 exact gigabyte, so you do like kind of 124 kind of things. So it's not that important, basically, but just, I don't know, I got used to like that. So if you want to increase this to, for example, 16 gigabytes, just write something like that. Okay, it's more or less 16 gigabytes. You don't need to be exact. It's however you get used to. And again, here, the W is the minute that you're going to spend. So make sure if it is short queue, don't go more than 240 minutes, because it's not going to dispatch your job at all. It's going to wait there forever. You think that it's running, it's not going to, it's going to be pending. Or maybe it's going to give an error. Let me see. Yeah, see, it's just run limit cannot exceed queue's hard limits. Job not submitted, even didn't submit. So you can, but I can do this with 240. See, but when I tried 241, see, I couldn't do that. So this is your limit for short queue. Yes, Mustafa.
Thanks, Alper. So I was wondering why we use W to denote minutes or time.
Let's
Like-
ask this to IBM. I don't know.
Okay. Is there a reason or logic behind it? I don't know.
You know, the people are doing, these are human. This is wall time. Most likely they use the W is, we have two different times. One is wall time, one is CPU time.
Mhm.
Means like when you run sleep 300, the wall time means it will wait 240 minutes, but
Mhm.
the CPU time will be 00001 because it's not going to use CPU at all, you know. So
Gotcha.
that's why I think maybe they use W. I don't know.
Thank you.
But we don't specify CPU time. That's why I don't know why they choose W. But you know, these are engineers, hardware engineers, so they can use different things. By the way, you're gonna see like, you know, star is written with someone else, high set written with someone else. So they all have their own background, and they might use different parameters for the same thing. So, but what you do for any command you use, you know, go to the like for example star manual. You're gonna do such things a lot. I do a lot. Like if you want to learn star, just search the manual for star and get the parameters from them. See, like, you know, they put all these parameters. Like for example, run thread n. I don't know. Like usually, this is not like this in other like for example, if you run high set 2, this is different. So you have to learn what parameter names they used, and then define like this. This is how we do. We learn from their manuals like this. Or you can load the module. Was it star? Small star something, 2.7, 2.7 something. Yes, 7. Yeah, it's waiting a little bit, but I just loaded this. Oops, maybe not this. Oh, I did it wrong. I loaded this, for example, and when you do month start, sometimes they have, sometimes they don't. See, this one doesn't have month start, but what they have, if you don't, some people don't prepare those manuals for their programs, and what they have, they write help, and you can reach their help like this. See, when I do the help, I see all the parameters here, and I can learn like this. I don't need to go to the internet. But again, like, you know, they give their names like this out SJ filter reads. You know, you need to learn everything from that specific application you're using, and they can do anything. And if you want to see this page by page, I'm going to show you later this too, but you can use this symbol in your laptop. It's on the right, on top of enter character. There's this pipe character there. What it is doing is basically sending the standard output of star help to more. So this is a more script. So when I do this, see, use it star, and the options and the parameters and stuff, and your reads file. See, for example, he says a dash dash reads files in, and in other software they might use input, for example, or input files. You know, it's up to their. This guy wrote this, Alexander Dobin, and if you have a question, just send this guy an email. Like, why did you give this name? You know, it's sometimes it's not intuitive, but it is how it is. I have the same problem. The software I wrote, I just define input, for example, for my input files. Okay, so let's go back, learn more about this. So if you want to give a name to your run, you can use this -J. Okay, so let's do that now. I'm going to do that couple. This is for sample 1, library 1, for example. Another one, 150. Sorry, I forgot to change. 150 seconds. You can give, by the way, you can give any name. You can give the same name a couple times. That's fine. You're going to see, I have lib1, lib1, lib2, and the other one is coming still. Lib3 came. Okay. These 3 are running on the same node. These 2 are running on the same node. This was 10 minutes, still running, 10, 12. It will run 2 more minutes and then die, or finish. So if you want to see the previous jobs you ran and their what happened to them, see, if you just run this like B jobs minus A, see some of them are running. These are zombie. They always there. I don't know. See, October 30, I ran them last year, and they're still there in my list to remind me that I had zombie jobs. And these jobs done, finished. So if you want to see what happened to this job, if there's an error here, or this is not going to work most likely because it's too old. Oh, it worked. Awesome. See, this was like term remove hung job. This is it's completed, it's exited the system, but hung job means HPCC admins removed this from LSF system. They removed that whole node from LSF system, and then the job stayed there forever. I don't know, not forever. They're gonna remove it in every 6 months or something. But if you see an error here, so for example, I'm gonna create an error for you. If I write a command that doesn't exist, should give an error. Slip, for example, this command doesn't exist. Still submitted. And I'm just gonna do the B jobs. See, it exit now, exits, because the output of my run didn't complete that command right. Means that if you do a mistake, for example, if you just do a typo, if you don't write the parameter right, one of those parameters you use, for example, if you use, I don't know, -r rather than -r, you just put a 1 there, -r1, it's going to give an error. So, and you will track down with these things. If it exits, you have to see what happened to that, you know. And what happened is this, minus L, this. So you need to see the exit status. So completed, yes, it exited, and term remove hung job remove. But exit code, you need to, it's remove the system, again, the same thing, but the reason is written here. Exited with exit code 2. So if it produces a code other than 0, it means that there's an error and you get this exit. Simply, now I will tell you a couple of things that how you can actually get these standard output in a file and errors in another file. Those kind of things I will show you. So you learned, so you can create logs using your output. Like B sub has these kind of parameters, like B sub minus O. So the standard output can go to that file, and error can go to another file. Okay, so I will come into here in a second, but I will just try to show you. If you don't have a bootcamp folder, this is gonna give an error. It's not gonna create this folder, so you need to create bootcamp folder before you run this. Or while you're running this, just run it onto your root into your home directory like this if you want. It's up to you. I'm just gonna do it like this for now. And just to show you, you can run this anywhere. Usually I use, for example, my project folders for this -O and -E options. So -O means the standard output, -E means error. So sometimes you want to run them in, put them into different files. So what I'm going to do here, I'm going to give a name, for example, J test1. This J, this is job name, I guess that's why they use J character for naming it. And I'm going to do, I'm going to create an error just to show you this. Maybe there's another thing, like for example, this is not exist. This command not exist. Okay, like you can do, there's no such command like this, and it will give an error. When you want to run this by itself, you're going to see that it's going to give an error, and that error will go here. I submit it, and see, look, when I want to run this, this command not exist, command not found. See there's no such command. This is an error, and the output is gonna go here. See, when I looked at this file, I got the errors here. Why this is
Question,
important?
Alfred?
Yep.
Question. I am getting B sub greater than sign. And I had to do a clear C, like a command C to stop it, to get to the dollar sign. I was getting B sub greater than.
Okay, you can just press Control C.
Yeah, that's what I did. I just wanted to know why. Is it?
I don't understand. Like, what's the question here?
Yeah, so when I removed the bootcamp thing and what you did, like then I pressed enter. Yeah, and this doesn't give me this command not exist. It just comes B sub greater than sign.
So what does it come like? You're coming here somewhere like this?
Yeah, kind of, yes.
Okay, so the problem there is if you open like a code like this,
Huh.
and if you don't close it like this, it's not gonna submit. Like if I don't close, I come here. See, this means that the job is not this like finished, fully finished. You can write other things here.
I see.
Now, when you close it, it will submit. You know what I'm saying? Like you can
Okay,
write,
okay.
write comments into multiple lines. It just
Okay, okay.
allows you doing that, but don't do that. Usually, just when you open something, close it. It can be like double quotes or one quote, but use the same code in both. Okay, like this.
Okay.
So now
I-
I'm gonna look. Sorry, B jobs. There's no unfinished job. They're all finished, and I got error here. Last 4 jobs, and I submit like many times. Test 1, so it's running them. Okay, you submit the jobs like this, that. And if you want to see the output into this output.txt file, you just like, for example, I'm just going to run this command, echo, I don't know, hello. Okay, see, if I want to use this code inside of my commands, you need to use like the one code here, and you can use like hello, something like this in the codes if you use one code. Okay, this is something that traditional Linux that it requires these codes, and it's not easy to usually learn first, but then when you open anything like this code, you need to close somewhere, and you can open another code inside, but this code, and I write hello and then close it here. If I don't, this is missing and this is not complete, and it's gonna give like it's gonna go to the same thing, like that symbol. So but when I do like this, say it's submitted, and now it's gonna write hello into this file. Let me check if it is finished. Yes, finished. Done, no error. Most likely my error file is the last one, because I didn't get error in this one, and this is not replaced, but my output is here. See, this is that echo hello. Which no, not the output. What's the name? Let me remove this and then summon this again. See, this is that job. Hello here, see? The output includes that standard output plus all the information about that. So you can track down your jobs. Like it tells you what job you ran. See, this is the job, like star command. If you run like huge star command, this will allow you to track down all the commands you run. This is important because if you get an error, you fix the error and resubmit job again. Okay, there's a question here, I guess. Not a question. Arthur just laughed. Okay. let's continue. There's one more thing that I want to tell you. This is kind of very interesting command that does something. What it is doing is this. So sometimes you don't want to put the error into another file. I'm just gonna, and I don't want to kill my job. So what it is doing is, like, for example, you're running something and you want to put the echo to your error. You know, you write a script, for example, you want to create error yourself. So this is, there are channels while you're running the command. At the end of your line, there are two channels. One is number 1, the second one is number 2. So if you use like this, basically what it is doing, the things in your standard output channel, if you put like this symbol and 2, it's going to send the things to your error channel. You know, if you want to like raise an error for something, you know, you're writing a script, you just want to put something into the error section, you can use that. It's like, oops. See the foo, actually in my error, if you want to test this worked or not, you can, this will go, for example, to your error file. The foo will go to error file and echo bar will go your output file. You can try, but this means that, you know, you have a full control what you're writing into your output files and error files while you're running your commands with these kind of things. If you want to put the error into your standard output, you can run it like that. Sometimes you don't want to kill, you don't want to generate an error, because when you generate an error, you know, it will do that exit, but you think that that error is not important, you can run it like this. It's going to just write that into the screen and it's not going to go to error file. So these are like, you know, when you start using these kind of things a lot, I use these things a lot myself. That's why I showed you. And there's a tip here, you can read them. So now let's go to interactive nodes. This is very important because usually what I do when I come to the cluster to respect other people, I never use head node like this. I always get another node, you know, like, but there's one command you see like who are not respecting each other. You know, everybody can see everybody. So when you use this ps-ef command, see, you see like everybody, their usernames here and what they are doing actually, what they run. So see, this person is running less command. This is okay. But I can tell like if anybody is doing, this guy is running Python. See, this is not good. Don't do that. Don't be this person. And we know who they are, you know. And this person is doing SFTP server, that's fine. This is just, this person is copying files from one server to cluster. You can do those things in the head node because they are not using too much CPU. It's just doing a copy operation. But if you run this kind of things, like Jupyter notebooks, they use a lot of memory, a lot of like, this is not respectful. Okay, don't do that. And you can check like every time what they are doing. Okay, by looking here. So lots of people are running this SFTP things. This guy, like, see, this is running a lot of SFTP. So if you're doing this a lot of like at the same time, I wouldn't do on the head node too, because you can always get a node and it's fast. The priority is really high. What you can do is basically this. So you're gonna change your queue because before you were doing like short queue, and you can change the, by the way, the location of these parameters is fine. You don't need to put the queue to the and or -w. You can change these groups, but after, for example, -q, you have to use one of the queues like interactive, short, or long. -w, you need to use a number, otherwise you're gonna get an error. So in this case, when you submit an interactive queue, it will give you a shell. Like this is the shell that I'm using here. This $, this is a bash shell. It's give you the same thing, but on a node. So let me show how it is going to work. I just copy this. See, it's waiting to dispatch and dispatch so fast. Why not? You know, and now I'm on a node. So let me see if I'm a node or not. See, I'm on this node now. See, this is a totally different node. It's not on the head node. It's belong to me now. It's using this. I require this much memory, this many CPUs, like, sorry, cores. And, you know, this is the defaults. And this many minutes, 120 minutes, 2 hours. So 2 hours, this belong to me. I can do anything here. And do like this, please. And you're going to be more respectful to other people. And you're going to utilize the head node's resources less for other people. Because there are like hundreds of people are using that head node. Sometimes when it gets stuck, you cannot submit a job. So please don't do that. Okay, so, and I'm now here. Another thing I want to show you. So I'm on the head node.
I have one question.
Question?
When executing this command, the one which you just showed us, interactive, I'm getting an error. It's like it's showing waiting for dispatch and starting on some number.
Yeah. And it's waiting too much, or just give it to you?
No, it has come out of that command.
But when it comes out, are you is it like this bash
No, no,
dash
no,
dot?
no.
Was it like
I
this?
have my username, that SR36.
But when you write like host name, what does it tell you?
It is C40B04. Okay.
Perfect. So you're already on the node. So it doesn't exit actually. It just gives you a new node, and it is not a head node anymore. So you
Okay.
are on that specific node. And when you write like B jobs, you're gonna see that you are on the interactive queue. It's running good, and you start your interactive job from a host, and it is running there. See, this is the job ID. That's good. So it's gonna run 2 hours for you.
Perfect.
It's just
Thank you.
you reserve that node for yourself. Not whole node, by the way, only one. But if you require the whole thing, just increase that the number of core minus n 8. Was it minus n? I forgot. Let's see. Where was it? Yeah, minus n 1. Just make it 8, and then you can actually get whole node. But if you ask 8, there's a bottleneck there. Sometimes they already give these nodes to everybody, and you can wait more. Even your prior queue is high, but if there is no such node that can give you all 8 free to you, then it's not gonna give you, and you're gonna wait maybe forever. I don't know. Like one node has to be empty. That will give it to you. So if there are like pending jobs in the queues, usually you're gonna wait, and you don't want to wait. Interactive
Yes.
queue means like, you know, you want to do something now, and you're there now. So if you want to kill this, by the way, I'm here now. You can exit. Just you can write this command exit, and it will exit there. But also you can do this. You can open another terminal and go to your SSH. I wrote this SSH into a script like this. I can show you how. I will show you how I'm doing those things. But see, B jobs. So I'm here on this. I'm doing some operation here. But on another terminal, you can do other things. While you're running something here, you don't need to wait to finish. It can run here. But then on the other terminal, I can do other things. You can ask another interactive job. Let me do that. Let me show you how it is going to work. Where was my interactive line? Here. See, I'm getting the second one. And then when I do B jobs, see, I have 2 interactive jobs. So you can get as many interactive jobs as you need. And you can run something here, and then you don't need to wait while doing more things, okay? But again, interactive means that usually if you're gonna run things on the background, you don't need to watch them like this, you know? And what you do, basically, when you submit the job to a short or long queue, you can close your computer and leave there. It can run there, and then when you come back, you can check if it's finished. You can do things with that, you know, processed files. So that's why, you know, you submit the jobs. Sometimes it takes a night, you know, you just submit there and then close your computer. The next day you come in to school and then continue working. So interactive jobs usually is for things that you are going to run here. interactively with the node, you know. But sometimes you're waiting like a minute or two. You don't want to wait. You just open another terminal. That's why I showed you how you can do this. And when I exit, see, I exit now, that job is still there. But you just don't want to keep it there for 2 hours. What you can do, you can kill it. So how you can kill it? There's a command, bkill. And if you're not happy, you started it. You can do this not only for interactive jobs, by the way. You can do this for the ones that you submit to the long queue or short queue or any other queue. By the way, these queues are defined for only our cluster. Okay, if you're running, I don't know, like you are affiliated to another university, they have a new cluster, another cluster, they might give different names. That's why, and they might use like other schedulers, like, I don't know, there are other schedulers like SGE, and their commands are more or less the same, but they are using a different naming. For example, for B jobs, they are using Q jobs in SGE, a different way of scheduling things. And it's open source, that one. This one is like paid tool, and UMass choose this one. We were using SGE before in UMass. They switched to this one. But other places they are using, for example, in MIT, we have another cluster we are using. It's using Slurm, another name of it, that scheduler. So you have to be sure what kind of scheduler you are using and use these commands for that specific scheduler. And there are a couple commands. Usually they are similar, like B jobs, Q jobs in SGE. Or, in another one, like Slurm, it's different name. But again, like, it's a command. You just get this like usage page, like a cheat sheet kind of thing that they have. They tell you how to run the commands, what kind of commands you can run. You learn fast when you go to another place, but more or less you do the same thing. You submit the jobs with a command like this. You list the jobs with a command like this and kill the jobs with a command like this. In SGE, it's like kill, something like that. I forgot. Okay, so I'm gonna kill that job. I don't want to run it forever. So another one is running here, because when you kill them, if you're not using, kill them, because other people can use. You can just do this, bkill, and it's being terminated. So it can still look like it's running, but it's going to be killed eventually. Okay, it's gonna go away. So like maybe in less than a minute, hopefully it's gonna go away. The other one is gone. Because I exit here, it was looking like it is not killed after I did B jobs, but there is like a delay, but it's gonna kill it eventually. Maybe say it's gone. And when I do this B jobs minus A, I exit. When I use exit command from interactive job, the job is done and it didn't give me error. When I kill it using an external, like command from when I was in head node, it exited. And you can see the reason here too. See, exited by LSF signal terminal owner. The CPU time used this much time because I didn't do anything there. And terminal owner, job killed by the owner. So I was the owner of that, and this is killed by me. Sometimes you saw that before, when you get an error, it still exits here, but some of the jobs killed by the LSF, or no, not killed, but get an error and exited. So you're gonna see these kind of status. Okay, I think there are a couple of things you need to understand here. Like, for example, when you determine the
I
resource.
have a couple of questions, Albert.
Ask, please.
Thank you. So on my terminal, I am using Mac. I do not see a plus sign to open a second cluster window or terminal window.
Here,
As I can see that you have a plus sign to add another terminal.
where is my here on this right side?
Yeah,
You don't have that?
no,
Interesting. Okay, you can use Command T.
Command T.
Other one. Yeah, T.
Perfect, that works. Thank you. I have another question. When we use the last command, is bash, I might have missed it. So what it is doing actually? What does is bash stand for?
So it is just giving you you can determine the shell, which shell you want to use. There are a couple of more shells like T shell, TSH, Z shell, ZSH, bash. Usually I use bash. Everybody's using bash.
Okay.
And this is just, there are some little differences. It's too much detail for you guys. Just ask this one, bash, and it will give you that the same thing on the head node. It's default, but you need to define something, and it will give you the bash that you can write the commands to terminal. That's how it is.
Thank you.
Okay, it's just a parameter. Just you can think that as a parameter. For advanced users, this is important, but for like advanced means like, you know, there are not many difference. This was like maybe 20 years ago, this was important, but today they're all very similar. But they are still using it, they never change. It's like, you know, you have a steering wheel in the car, but you can use buttons for a steering wheel, but we're still using steering wheel. This is such thing, you know. Okay, so there are a couple of advices you can read here about how you can decide. Again, I explained how you can decide your queue, how you can decide the time limit that depends on the software you're using and the size of your data. And a couple of runs, you can have an idea about the time limit, about the memory limit. You can ask us, we can give you like a bold idea. Like, but this is again, like, for example, sometimes I'm giving an advice about like, you know, if you have 10 million reads, you know, like 16 gigabytes enough for start. But sometimes that 10 million reads are mapping to repeat regions. And when you map them to repeat regions, it is using more memory than actual reads that can go to anywhere in the genome. Then in that case, that 16 gigabyte will not be enough. That's why we are not telling you the, like, you know, God-given like kind of word about the memory usage will be this for 10 million. It's not always like that. It can be different for your usage. Or you have 10 million reads, but it is for, I don't know, like you're using a smaller genome. Maybe, I don't know, you're using a Escherichia coli or something like that. I don't know. And it's much smaller. And then when you map that, it's going to use only, I don't know, kilobytes of memory, maybe a megabytes of memory. It's very little. So you don't need like 32. If you're using like human, it's going to use this much memory. If you have smaller genomes, if you are using bacteria, if you're like, it's a totally different world. Even when you have 10 million reads, it's not going to use that much memory. So, but you learn this by looking at bjobs minus L command. You're going to learn those kind of things. And the number of cores, again, like usually we increase the number of cores when we are doing this alignment step. You know, when you start HiSet 2 or Top Hat or like sometimes Callisto, like, you know, when you run this kind of software, you can increase the parallel jobs to process one sample. And you can increase the number of these cores while you're submitting job. But then you're going to learn like this is not enough to utilize all the cores by just asking is not enough to utilize them. So what you need to do is while running the star algorithm, there's also another parameter in the star algorithm, like star-n or something like that. You have to write the same number there. Otherwise, if you don't write, default is 1. So you can ask 4 while submitting the job, but while running the star, if you don't put that 4 there into star, then it's not going to use that. It's going to use 1. So, but we're going to do this like in 2 weeks. So you're going to learn this. So other things like advices, do not use the head node for big jobs. Means those kind of like the real jobs. I never use head node, by the way. If you use me using it, just send me an email. You said that you never use, but you're using now, you know. You can do PS minus EF to check who is doing. And see, the advice is do not run the programs on the head node. It will, if it takes more than 5 minutes. Even I do my FTP jobs on a, you know, one of those interactive nodes, or I submit the FTP to copy the files from one location to another. And you're also using your space and you're sharing nearline and project space with other people. So also be respectful to other people there, that after you finish your job, if you're not using files, just remove them. Get your backups and remove them, especially for intermediate files. You know, there's a, like, you know, what I do, for example, when I have 1 gigabyte of files, samples, if it's 1 gigabyte, while you're processing that data, usually you use like 10 times more space. It becomes like 10 gigabyte. If you have like 1 terabyte of files, you might need like 10 terabyte of space to process that data. But maybe you have 10 terabyte already in your storage. So the idea there is like, don't keep that intermediate files there. Just remove them. If you need them again in the future, some of the intermediate files will rerun. Like rerunning is cheaper because it's free than like keeping the files in the storage. If you need any intermediate file, just remove them. Unless like if you need to use them in 1 week, just keep some of them. That you might think that you're going to use some of these alignment files or something. You can keep them, but remove the rest, whatever like you generated. So make sure that how much space you are using. How you measure your space usage. So there are a couple of commands you can use, like df-h dot. It's going to show me how much space I am using where I am now on here. See, this is I use almost all of it. See, 100% on my home directory. This is my home. So I need to remove some files here. So because when you fill that space, you cannot write anything there. And many of your jobs might fail if you are using everything in your home. This is too less. So I haven't been cleaning anything lately. That's why maybe it filled it up. But once in a while, come and like clean the things that you're not using. And if you want to check another directory, just write it like project BMW biocore, for example, how much space I'm using there. See, only 500 gigabytes available now. So you can get a list like this. I'm going to check my nearline space. See, 7.4 terabyte is used. I have like 7.7 available, 50% I'm using. That's good. So another thing that you could do, this is df-h is going to show you the whole file size. Some of you guys are like measuring the size of the usage of a directory with this. You cannot measure that with this command. This is going to tell you the whole that storage space. I have 3 storage, home, and project, and I can measure like this how much space I have. But if you want to measure a specific directory, like how much that directory and files under the directory keeps in my storage, then you can use the du command, usage for that directory. You can do like du, like if I just run du, it's gonna tell everything on my directory there, in my home. But I don't want to do like that. I just want to show you, like, for example, du minus LSF directory. There's nothing there, but let me show you, for example, du minus Dolphin directory. See, it's telling you like all the files here. But if you want to sum them up, you can use like summarize. You can use summarize option, du minus 8th Dolphin. But this is not like human readable. So we have another option here. sh. See, 229 megabytes. So I can, with this, like you can look at like where your files, for example, I don't know where they are, but for example, I'm going to check this. Oops, I couldn't copy. du minus sh. This is small, maybe test variant analysis. Maybe this one has a lot. See, 2.6 megabytes, not much. Maybe my R is huge. 243. See, my R, I might want to remove that. This is 225 megabytes. You might need to choose removing those, or this one, just one file. You can either do this or minus this. See, this file, genes GTF. So you can actually check like this with du minus sh command. Okay, any questions? So you're gonna do your homework later. You're not gonna do it now. And maybe we can give another 10 minutes now, and then I will show you some useful commands in the last hour. So we're gonna learn when you run any process in the cluster, anywhere, like in your, or even on Mac. So what they mean, like foreground, background processes, this management of them, and the pipes that I showed you, and a very useful command grep that you can actually search some words or some patterns in your files. That is very useful. And I'll use I'll show VI. These are very hard, very advanced, but once you learn, they're beautiful. You can do many things with them. In one line, you can do lots of things. You can write it like a script kind of things here, and then you're gonna have your homework that you're gonna do later. Okay, so let's do 10 minutes and come 11:05.
I have a question, Alper. You want me to ask now or after 10 minutes?
No, ask now. The people can go, or if they don't want to listen, yeah.
Thank you. So actually, I am finding it hard to read the help of commands or sometimes even the manuals. For example, if I go to bjobs help.
Yep. I'm going to share my screen and I'll do it for you.
So I don't know how to go around this help, because it's telling like there are categories like filter, format, state. There are the different options given, and then those options are not explained. So I do not know how to
Okay,
get
usually, okay, there's
useful
one
information from there.
Yeah, there's one nomenclature here. It's about, like, you know, you have your command and the options. Options are usually here. See, categories and options. So options are going to be in this page, and see there's options, and then now you're going to start seeing the options there. So for example, one option is -A.
Okay.
And another option is -G, but you need to give user group. And this is the description.
Yeah.
And another option is -JD for the job description. You know, when you're just want to filter. So you might have, imagine, like 100 jobs listed there. You just want to list some special description in that list, just to filter. So category is filter. See, but this is their, like, whoever wrote like this LSF thing, they choose this. Another command like man ls might be a little different. See, this is
such kinds are like easier because I can see that the options -A. So do not ignore entries starting with. So these are like explained more detailed, or at least I can
actually this is
understand.
the other one is more detailed. See, this is just one thing, and they explain like crazy. You know.
Okay, but if you go to like category filter, for example.
Yeah. Lots of filter, like
No, actually, when I'm opening, it's different. I don't know. I am doing something different or what.
I just did man bjobs. Did you do that?
I did. Okay. I did help actually. bjobs -help.
-help. Sometimes -help, sometimes -help. But in this case, it's -help.
Yeah,
That's
this one,
like this.
for example. Yeah.
That's a different way of showing the same thing. But you know, it's here. See, bjobs options. It's just put all the options together. It's not giving you the explanation here.
Okay,
you know,
and then
Yep, tell me.
So in that case, I should go to the manual, right?
Yeah, if you need more details about -A or -E's, like whatever you have here, if you want the details, you need to go to here, and then search for, you know, -A. bjobs -A, and it's the details, the description here. Okay.
Oh, perfect.
For example, I'm going to submit a job, and I'll show you one cool. Sometimes when you're submitting a job, where are my jobs? Okay, for example, this interactive job. I'm going to submit one job. Okay, so for example, this job, I want to give like a huge name, sample 1, for example. This is my, and when you do this, when you run this, there's a huge name, and there's one, I'm going to put a sleep here just to show couple, and sample 2, and sample 3. And your names are huge. And when you do the e-jobs, oh, good. Sorry, it's here, sample 1, 2, 3. But
Yeah.
if you put this, sometimes, you put the huge name after sample 3. You put it here, sample 3, huge name. And if the name is like this, you cannot differentiate what they are. It's coming, come. See, sample that 3, that is like in the prefix of the name. And then you cannot differentiate if you do this couple times, like sample 4, sample 5, and you don't know what it is. They're all the same, look like the same.
Yep.
See, all the same. So, okay, what is different? So you can use like -w. So this is going to write the whole name.
Okay. Yeah, I understand.
Sometimes there are lots of options like that you can use. Like there are other options for filtering, like specifying some specific jobs, or the format of like how you're getting the list, or like which hosts you want to get, or applications, like lots of things that you can read and learn. But there are like for example, not ls. ls is many different commands if you just want to get the directories. Or let me show, for example, a very cool thing. You just want to see like which files that I recently created. You can use -lt. It's going to order using this date. See, I just created these. It's sorted using this column, the date column, 13 today. And those are here, -lt. So, you can learn like all these things from this ls, or help. That should be help. And if you just want to get the directories, for example, you don't need the files, -ld. Sorry. Oh, sorry, where am I? Interesting. It's just giving itself. I don't know. This was working before. I don't know. Am I doing something? Generate this directory entry instead of contents. Interesting. I don't know why it didn't work there, but this should work. Maybe let me try on my Mac. Interesting. But there are other ways to do that. It's just showing where you are. Doesn't make any sense. But yeah, it's not working like always how you expect. But there must be a reason for that. Why, you can, by the way, you can search those things on the internet if you need to use these things a lot.
Yep.
You can always get the explanation on the internet about why this is not working how you expected, or the people are discussing these things on the internet. And in times, these kind of commands change too, so be careful. Look at the date and try to use the recent forums and recent publications and stuff about this kind of commands, because they change in time. We have 1 more minute. Okay, so everybody's here. Let's start. Any questions before we start, by the way? Because I'm going to start showing some difference between the processes and the jobs. So there are two things we are doing on the cluster or on your machine. So I want you to separate those things in your mind while you're running any command. Any questions before we start about submitting jobs?
But I have one question.
Yeah.
Like you said,
Yes.
it's all about trial and error, right? I'm talking about the command which we have to mention about the memory space, the time required, and either it is long, short, or interactive. The first,
Right.
very first command.
Yeah.
So,
Let me
yeah, my
go there.
question is, for each and every job when we need to submit, should I write it to you and get to know what type of memory, I mean, the requirements, and then submit it,
No, don't.
or how it does this?
I wouldn't suggest that, but you know, in a couple of weeks, you're gonna learn this Dolphin next. And what we are doing, usually all the commands we are running here, for example, RNA-seq pipeline, we're gonna show these kind of things. You can learn these things yourself too. I would suggest running these things a couple times for yourself. But look, for example, there are many of them we are using like short queue, like 10 gigabytes of memory, one CPU, 240 minutes. So this is gonna go to short queue. So run many things in the short queue like this and see if it is killed, if it is like star or something big. You know, you can learn here, like for example, Callisto. We use long queue. I don't know why we're using long queue here. Callisto is fast, by the way, very fast pseudo aligner. Maybe because this is going to 240 minutes, it should go to the short queue. So don't do these kind of mistakes. Don't trust everything we do here, right? So do use your own judgment. See long queue, for example, here, I ask 2000 minutes. So this makes sense. But the memory is less because I don't know, like, again, like maybe this worked for merging BAM operation in HiSet 2, it requires 8 gigabytes. You can learn many things from here, but use your own judgment too. For example, in this case, HiSet 2 creating index files we know that it requires a lot of memory. And then we increase that to 50 gigabytes. And it takes time, 3000 minutes. How we are doing this usually is like this, you know, we are just running this couple times, and then when we get an error, we come here and then changing these parameters. Yes, Mustafa.
All good, thank you.
You got it? You got the answer?
Yes, thank you. Yeah.
See, we have lots of things here, like lots of things you can learn many parameters from here. Again, try it. If it doesn't work for your case, increase whatever didn't work for you. Like memory didn't work, just increase that. Time didn't work, increase that. How you learn it again, you're gonna use this bjobs minus L command. By the way, this A command is gonna show like finished jobs or exited jobs, error jobs or zombie jobs, all the jobs you have in your history. This one, bjobs minus L without A is gonna just show unfinished jobs. There is no unfinished job here. That's why it didn't list anything. If you just want to see what jobs you had without listing them, see, I did lots of runs today. I used a lot. And if you want to go to a specific job to learn like how much memory you use, how much time you use, just use the specific job and learn from here. How much time you use, the memory, and it's gonna tell you like memory usage here. See, 8 megabytes, nothing. So, but if you're using star, you're gonna see that this number will increase, and then you can adjust yourself. A couple of runs, you're gonna understand here, and then you don't need to ask. Of course, like, you know, you can ask like initial questions. If you never run, and if you don't wanna fail, you can always ask us. But again, like when you do these things, like for every single, because you're gonna run 100 programs, you don't wanna ask those questions to me 100 times, you know?
No, I got it. Thank you.
You can learn it like with your own errors and trials. Okay, so let's go back to here. Okay, so there is a thing that when you run the job, you know, you're running a process by submitting that process into a node. Okay, that is a job run, but you can run multiple processes with a single job. For example, I want to show you one cool thing that I'm going to show you VI later, like an editor. You can write comments into files. For example, I want to do this. I don't know, like sleep 300, like 300, like 10 minutes. This command into a file. Okay, into a file means like S300. This is the file name I'm defining. There's no such file exist in my directory here. But what I'm trying to do now, if the file, or let's do this like very useful command that you might want to use a lot in the future. So in my history, I remember that I run this bsub commands a couple of times. I'm going to show you grep in a second. So in my history, I have a lot of things here. Okay, so but I just want to grab only the commands with bsub in my history. See, only the things with bsub came here. What I'm going to do now, I had the interactive queue here. Where's my interactive queue? Here. Okay, so in the history, this number is, if you do like this, like exclamation mark and 1077, enter, it's gonna run that command in your history. See, it just ran this command, bsub, and ran and gave me this. So always work like that. But there's another way you can actually work with this command. You can simplify it, like putting this into one of the files. For example, I usually use this bin directory. Okay, I want to create a file like interactive in interactive queue. Okay, interactive inc. I just create a file like this. There's no such file. Okay, I'm just going to create this with like echo. I'll put this command into that file, and this will create file, and it will write this one into this file. Okay, and then when I do this, and I'm going to look in inc. See, it's there now. So I don't need to write this again and again all the time. I can actually run this command and then get my queue faster. So, but maybe you don't have bin directory, by the way. You can create bin directory like this, and then run this like I did, and I'm going to have that inc. So, but here, what I want to do now, like if I want to run this like this, it's not going to work. Why? Why do you think it's not working now? You learned this last week. Any idea how can I make this work? I'll show you two ways. Any ideas? Please, I expect people here and knows this.
CH mode.
Again? Yes.
CH mode.
Perfect. Who told you that? I missed it. Who are you?
Yes. I said CH mode actually.
Mustafa. Perfect.
Mustafa, yeah.
Okay, so that's true. So you can use CH mode and change the permission for this. See, it says that permission denied means I cannot run this. This is not an executable file. How can I tell this? See, I use my ls-l command and looked at it. It's not executable. So what I can do, I can use CH mode, as Mustafa suggested, give, like, for example, to everybody, this plus X will give everybody, like means like to me, to the owner, to the group, and to everybody who can access to these files on my own folder. You can share this with other people in your project space, with your group members or everybody else. So now I gave this minus X. See, X came here. It was like this before, and it came like this. Now, the cool thing I can do, and then bin inc, see, it ran. So you don't need to run everything. This is gonna give you like a lot of like simplification and making things faster, right? Because every time when I come here, actually I had this command, queue login. This is like interactive queue for me. And it was doing the same thing. But this time I just gave another name. You can give any name, by the way. But remember that, or you can always ls. So I do this a lot, like in my bin directory, these are my binaries, or I create lots of files like this. And for example, I have, I don't know, like trim.bash. I gave that name. You can give any name. This is yours. Nobody's gonna see them. So for example, I'm gonna show you what I did in trim.bash. See, I'm running multiple, this one out command just to trim like first hundreds nucleotides of the read and put them into another file. And $1, $2 you're gonna see. And I can do this with any file. And I'm only applying this to every second line. I'm gonna talk about the FASTQ file, and every 2 lines, you're gonna have the read and you're gonna have the quality of that. So I'm gonna talk about this next week. So you can do such things with awk that I'm gonna show you later. But it is kind of cool thing that in one line, you can actually trim your reads yourself without any other program. There's a trimmer, by the way, programs and such things that you could have used. But in this case, I just write one line. It's magical. And you're going to learn these things if you invest time. So, but what I did was I just put this into this file. Whenever I need this, I don't need to run this out file again and again. But I just do this. Like bin trim, for example. And I give the file name. It's $1 means it's taking this as a parameter into this bash program. Like for example, a.fastq, I don't know, whatever. And the second one is my output fastq, another name I give. And it's gonna, if this exists, it's gonna run it and then do it there. See, I'm already here on an, it's not, this is not on the head node. So I can run this, sorry. I can run this on this node. And if this is a short, small file, if I think that it's going to finish soon or in a couple of minutes, I can run it like this. But the thing is, when I run anything like that, even like the trim or whatever, so this will be one single process. By the way, you can put multiple lines here. You can do multiple commands one after each other, you know, and you can put them into a file. And then when this is finished, you can run another one. So, but there's another symbol here. So these are the things that I want to talk now. So when I do like PS, this is a root process, a root, it's running there already. So I didn't run that. This bash is, I asked the bash and it gave me the shell and it's running as a process. You know, it's giving me an application to run my commands on the bash. So PS command, I just run now. So all the process can be listed like this. In this specific terminal shell that I'm running. But if I want to see other people on the same machine, I list everything. Like most of them are root. And this is also another like system user. This is system user. This is another person. See, I'm sharing this node with another person. It's not me. This is me. This is me. These are mine. So you can actually see what other people are doing here. So this person is running this LSF command, like it's doing some batch operations. I don't know who this person is, but so you are sharing this node with someone else. So you still be respectful. For example, if you're an interactive node, if you ask one core here, because there's 8 more. So 8 more people might get in here if everybody asks one core. So you can still run these things here, but we don't ask like more than one core, for example, when you're running start on an interactive node, if you ask one. Okay, this is the thing I wanted to tell. And when you're running anything here, any process, so there are like 2 types of processes. You run the process, for example, sleep 100. When you press this, created a process. Okay, now I cannot do anything because this has to run 100 seconds and then it will give me back this prompt back after 100 seconds. Okay, but I can send this process. So this is in the foreground now. I can send this process to the background to do more things while it is running. Okay, I can do with this Control Z. See, it stopped the process now. It's not like counting this 100 now anymore. It stopped, but it's still running. Means it's kind of paused. And the process number is this PID, process ID. And it is my process sleep. It could be star or any other process. And if I wanna like continue running in the background, yeah, I can do two things. One is like, this is just, I can use BG, you can use this Control Z is gonna send you the background. If you press Control C, it's gonna kill it. It's not gonna keep it and pause it, okay? It's gonna kill it. So don't use Control C if you wanna send it to the background and start using the terminal and do other operations when it's running in the background. That's fine. You can do that. So, but when I'm doing this BG, it's going to run this again. See, sleep started running on the background. You see end here. Basically what you're doing is this thing is sleeping now, like 100, but in the background, it's not doing anything. But when you run star, for example, in the background, you want to see other things going on in your storage or other things. You want to use the same shell, you can send them to the background, send the process to the background. So it's still continue and done now. So when it is done, like after 100 seconds, it's going to write it into your screen, wherever you are, by the way. If you're in a file, in an editor, you're checking, it's going to write it there, whatever you are, wherever you are. So when it is done. And that's process number that you send to the background, it was the number one. And if you can do this couple of other processes. By the way, I did with Control Z, but you can send the command to the background with ampersand character here, like this. It's in the background now. I'm going to send another one for 200 seconds. Another one for example, 150 seconds. See, 1, 2, 3. When I do PS, I have like 3 processes are working. See, I want you to understand these are not like jobs submitted to the queue. I'm already running this on my interactive job. I can run multiple processes. Okay. And if I want to kill one of them, like for example, this was going to wait more longer. So I can tell like the number is going to be bigger and bigger. So if you want to, I know that the 100, 200 and 150, I just want to kill this one, for example. You can use like kill -9, this, or this is forcing. Usually we don't do like that. But if you want to force that one and kill faster, you do like this. In PSC, this is kill. But this is like different. Like I want you to understand the difference between like B jobs. I have 2 interactive queues running, for example, there. And one is submitted from here. The other one is submitted from on top of this. So you can do such things. But I didn't kill my interactive job. I just killed the process I'm running interactively. Okay, I want you to differentiate what processes. I want you to differentiate what the whole job is. In one job, you can run multiple processes, many processes, okay? And or one process, it's up to you. But again, when you are an interactive job, when I'm running these kind of things, you can, sorry, like this is done to sleep 100, but there was another 150. I want to get that job to the foreground. You can just press FG. So this job came back, see, 150. So any questions here about the process and job, like job definitions? So in process, for example, in your own Mac machine, this is my Mac machine. And here, PS, I'm running like, I run connection to my cluster with this. And in another terminal, this is also another connection. Another terminal, I have like 3 connections to my cluster in 3 different terminals, okay? Because I'm running many different things. So I can see them. If I want to kill one of them, I need to kill this. Or I cannot submit jobs here, by the way. It's my laptop, B jobs. There is no such thing here. It's not cluster, it's not head node. But I can still run the sleep 100 as a process. I can use Control Z and it's suspended, paused. It's here, it's not running now, it's paused. If I do like foreground, it's continued. Again, Control Z, I send it background. If you want to keep it in the background, BG. See, continued in the background, I still have the prompt that I can do other things. Okay, I want you to understand this logic, how to send this thing to the background, how you bring them to the foreground, how you can do the list of this. PS minus EF is going to bring like whole list with coming from all the users, root users, everything. PS minus F is going to bring the things which belong to you in that specific shell and running, like see, this was running there with a longer version. PS is just going to bring the same thing with a shorter version. This PID is important here if you want to kill them. And there are some more explanations here. You learn killing. And if you want to see, like, for example, I am here and I'm trying to run something here, but it is too slow and you want to understand the reason, you can use top. And when you use this top command, you can see the users here and what kind of programs they are running, how many CPUs they are using, how much memory they are using. Here, memory, and how much virtual memory they are using. Virtual memory is if the memory is not enough, it's using your disk in that machine and start writing there. But the memory is 1,000 times faster than a virtual memory because virtual memory is like actually a disk. It's writing the things that needs to go to your memory to the disk. It slows down your job dramatically if it is using more memory than you ask. But usually, if this is a normal machine, if you're using on your Mac machine, like for example, I can do here too, top, just to see on my Mac, sometimes it gets so slow. You have lots of things running. Some of them are sleeping like this, but you see how much memory you're using here and how much virtual memory you're using, how much CPU you're using, what is the process. If you're running something here and you forgot and it's running forever, maybe in a loop or something, if it is your thing, you can kill it. You can actually monitor your system and see what is wrong within your system. And for example, I'm using Zoom here. It's using a lot of most likely memory and CPU. See, it's using more than 2 CPUs here. My Zoom. You see here how much it is using. And more than 2 CPUs actually. And how much memory it's using, like 339 megabytes. And like I'm using, for example, GoPro webcam now, and it's using more memory. Sometimes it's stuck your computer. You don't want to, if you think that your computer is too slow, just remove some of those things and don't use them. And you can visualize them here. And with Q button, you exit from the top. Okay, this is or Control C or Q. It's going to work. And so now let's talk about pipes. This is a very cool command. And what you're doing, any questions here, by the way? There's a question here, maybe. See, for example, we need to clarify this one more time. We are not sending a job to the background. Job is submitted job to the scheduler. They're already in the background unless you submit the job to your interactive queue. And this is not a process. We are not sending the jobs background using this Control Z or running with an ampersand, okay? These are processes. Those are not jobs. So this is a wrong nomenclature. So please be careful here. When you submit a job, it's going to the background already, and it's a submitted job, schedule, dispatch the job to run your processes on that dispatch node, okay? It's a different thing than running a process. It looks like they're the same, but I want you to understand what cluster is, what you are submitting to the scheduler to dispatch your job, and in that node, you can run multiple processes. So there's a difference between the job and the process. You can send the process to the background with Control Z or ampersand, not the job, just the process. If you want to send a job to the background, you just submit it to the long or short queue. Okay, that is the job. That when you send them to the long or short queue, you just submit them to those queues and they're going to run in the background. But whatever run inside is process, inside that thing. You can run one process like start or sleep we are doing, those are processes, but you are running the processes inside of that job, submitted job. So I know you think that it's the same, what's different? No, they are different. So one of them is using different like nomenclature, different naming, like processes like that, and the other is jobs. Jobs only can be submitted. So you cannot use ampersand, or you cannot use like Control Z's to send the background or something. Okay, this is something important. And it looks like complicated, but I am trying to separate them. Job submission is different, process, running a process is different. We don't submit a process. We submit a job, we don't submit a process. So these kind of things, when you're using the wording sentences, important to tell us when you're explaining your problem. For example, I submit a job, and we know that you use bsub command to submit a process that you want to run on that specific node. We will know like that. This is your cheat sheet, by the way. We put everything here. This is your cheat sheet. You can learn the commands here and then do your homework. And you can search cheat sheet too. Like, just go, cheat sheet means like if you need a one-page sheet, you can search like, LSF cheat sheet. You're gonna get lots of pages about these commands. Or Linux cheat sheet. You're gonna get lots of cheat sheets. You're gonna choose whatever you like. And they're gonna put all these commands there. Okay, let's go here. Pipe. So pipes are so cool that you can use everywhere. So any command, I'm gonna exit here. Any command you run, like ls, for example, you can use the pipe and use another command after that. What it's gonna do, it's going to send the output of this command to this command to do something. For example, I do ls and I'll grab, for example, the files that includes text in it. See, just bring me only the files with the text in it. So grep, you're gonna learn more details later. So what it's doing, basically, it's just not, it's just getting only the subset of these files that includes text that takes the in it. Okay, or like blast, for example, in here, you can do like that. Blast space blast. See, I have blast out, mega blast inside somewhere. Or what I'm gonna do now, for example, ls, and I want to count how many files I had in my directory and directories. So this is going to give the word count. So when you count, there will be 40 files and directories here, 40. See, if you just want to get that 40, this is the character count, 425. But if you want to get only this count, you're just going to use like this parameter, for example, 40. Sometimes we use this. When I'm using this, for example, I want to, like in method that takes the file, what I have here, this is metadata of lots of things going on here, but I want to see how many lines I have there. I can do like cat, just right here to the screen, and then send that to the thing that I like word count program, and there are 57 lines here, just to see how many lines I have in this. Sometimes I use this WCL a lot when I want to, like for example, count the files in this RNA-seq, for example, where was my reads? I want to show you, like, you had this control rep fastq file. This can take time if the file is big. These are small files, only 3 megabytes. Usually your read file will be like gigabytes. You need to wait them and then send them to the background. That's why I showed you background option. So what I'm going to do, for example, I'm going to either cat them, like one of them, for example, rep1, fq, and then quantify how many lines I have. Oops. What did I do? Oh, don't write with your hand. Just press tab. It will give you options. And I forgot this one. Give me error. There's no such file. That's true. because there's 1 and 2 here. So when I do this, these are that many lines I have in those files. So you could have used like this too, by the way. You don't need to do like that for the specific command, but sometimes you use this pipe. See, this would work too. But this pipe is a cool thing. And if you want to, if you think it's going to take a lot, like a little time, you can just press and then send into the background. It will give you the process number, and then when it's finished, it's going to write it wherever you are. You can do that. But if you want to write this into a file and then run into the background, like, for example, this lines for this file, I'm just going to put it here for now. I run in the background, and no, sorry. See, I just put these lines, and it just wrote the reads here. But if you want to put the number, you have to put this here. Okay, so when I do that and I run it in the background, I immediately get my thing. It's done, because these are very small files. And then now when I look, see, this is right. So where you put this symbol is important. So don't think that you can actually run this and then send the output, standard output this. So because the first time when I do this, I put that into here, like what I did, cat, control fast Q, and put the output of this cat operation into here, not this one. Okay, but when I do this, thing, the output of this operation is nothing, 0. And the number of lines in nothing is 0. See, it wrote 0 here. Okay, so be careful what you're doing, and put things in an order and understand what this is doing and put into the right place. Okay, so that is cool. I'm using this a lot, so you're going to use those kind of things a lot. So these are the examples. Now let's learn grep. This is a very cool command. So for example,
I have a question, Alper.
yeah, please.
Sorry. For the pipe, so what is the general principle? So we have a command. So can we have like command options, arguments, and then pipe command options and arguments, or
Exactly, it's always like
general
command options. Exactly, but think about like this: the output, like I can do like multiple things. For example, cat do. I'll do this. This cat will write everything. Like, for example, let me do like this. Sorry, that to show you like multiple. Cat is going to write everything here.
yes.
And when I want to grep only the reads that has AAAG in it, for example. See, these are only those reads. But in those like AAG, for example, here.
Mm-hmm.
Okay, and let me color that, you can see better. This is what I was going to show you actually now, like color always. See, AAG is here, but what I want to do, like I want to get these AAGs something, and I want to get these guys too, CT, GCTA, like after that. So you can use one more pipe, grep this. See, only these guys have that.
Yeah.
Let's see, color. See, these guys only have these AAGs and this. So see, for example, if you're looking for an adapter or barcode sequence, you can use this pipe multiple times to filter some of the reads and find the ones that you are looking for. Sometimes, you are using like a 5' adapter and 3' adapter.
Mm-hmm.
You're just designing a I don't know, barcode, and you want to sequence a barcode after, and you want to deliver some viral sequences using some barcode, or you introduce some mutations in somewhere and you want to introduce that sequence as a microRNA, for example, or something, just to test if that microRNA is going to have a function on that specific cell. I'm just like telling you lots of other possibilities. But after you sequence, you want to see that design, if that design is in your sequencing files or not, just to see that your sequencing worked. But when you're designing, you do your design work like this. For example, you design one barcode with this AG, another barcode with CTG, CTA, and you put like maybe 21 nucleotides here in. And you want to check how many of your reads actually got that sequence in. And if it is not that many, it means that it didn't work. So without a bioinformatician, you can just run this command and tell that your experiment worked or not by just checking this. And you can run this in your laptop too. So this grep is a very cool command. You can do many things. Again, like how I showed, there's an homework for you, great homework there that you can do. So another thing you could do, for example, how many of my sequences have actually, you can still run this, but how many of my sequences have AAG and CTG inside? See, 2,779 sequences in your reads have that. See, I'm just showing you how it is looking. So you can do such things, but if you want to define the order, see this.
So one more question. So if it's beyond the scope here, so I can discuss later. So for example, if I want to look for some motifs or some short sequences in a genome, and I want to know the coordinates where they are located in the genome, would it be possible using this command like
No,
grep?
this command is not good for that, because that is like this is, you're just doing like a kind of preliminary thing just to check the sanity of your reads, you know, like how your experiments worked or not. So this is good for those, just to check. But those kind of things are done with motif search algorithms that we are using, like, you know, Homer, for example, are doing that. Or there are some databases that are telling you that which genes has this motif, because motif search is not like this is kind of exact search. But I'm going to show you not exact search too with this. You can still do this, but there's a better algorithms actually can do that, allowing, like, for example, like you can give not only that one AG, but you can tell in like first position, like 70% A, 30% G, for example. You can give a matrix to the search algorithm with the percentages of AGCT, and then you can even create like a, you know, logo of the motif and a search that specific motifs with like including the percentages for the motif locations, because, you know, motif means that this maybe there's a binding site here, but the binding affinity like is important for a couple nucleotides here, but not all, you know, like A 100%, G 100%, but this in the middle, like this 2A, maybe it's 50-50, you know. You cannot like do this kind of exact search. You need to introduce that percentages per nucleotide to do motif search. Okay, that's why we have lots of different algorithms, programs. Star, for example, doing like searching this whole read in the whole genome by allowing a couple of errors. So if you just try to search this with grep, you don't know where the error is, you know, and you cannot just introduce error anywhere with the grep grep program. That's why you need an algorithm to do that. And for those algorithms, for example, we're going to talk about them. They're using like some like dividing these reads into like smaller chunks, and they preserve the order of this like this whole sequence, and just mapping them by masking some of these nucleotides and aligning them to whole genome, and allowing like errors and finding the locations in, you know, multiple parts of the genome sometimes, and finding and detecting the best origin of that read, and scoring those reads and telling you the coordinates. So you have to do such kind of operation to find the origin of the read in the genome. So not with grep. Grep is simple, just, you know, a couple of lines and fast, you get right there. But here, for example, I searched AG and CTG, but I didn't like require which one is going to be the first, like before AAG or after AAG. When I do this, see, some of them CTG is before, some of them after. So, but if you want to put them in an order, you can use this wildcards here too, like this. For example, I'm going to run that, and see, it's just started and matched the read starts with this and anything in between and TGA. But what, sometimes your adapter sequence is just very defined for this. And sometimes, again, it's the thing that you want to use, for example, in the middle, and then you want to trim them out. But this is just for sanity checks, okay? You're not using this just to check or do the operation, because what we're doing usually, even this is barcode, you can allow some mismatches here, and you don't know where the mismatch is, when the error is, because these are not like always these sequences. When you sequence, there can be some errors coming from the sequencing machine. And next week you're going to see that in these files that we're going to mention, that you have your ID of the read, you have the read, and you have quality line here. For each nucleotide, we're going to talk about the quality, and that quality will tell you the accuracy of this sequence nucleotide, means like how accurate that C is. Like if the accuracy is low, then we're going to have with this symbol here. If it is high, we're going to have that information, and we're going to show you how you can actually run QC just to check if your these scores are low. It means that when you do the grep like this, maybe there's an error there, and you don't want to miss those reads there. Maybe you can introduce. Usually those errors are like very low, like 1 or 2%, maybe less sometimes. Today's technology is less than maybe 0.1%. So, but still, you just want to introduce one error, because if your adapter sequence is like lots of nucleotides here, you can introduce one error anywhere here, anywhere, and a grep is not going to work for that. We are using like Trinomatic or different algorithms to allow that error to match to this site and trim that adapter out and use that sequence we introduce to try, for example, in that specific cell type. So that's why this is the easy version. Just will tell you like how many of my sequences have that, just to do your fast checks. Maybe there's no such thing, by the way, because I added a couple of more. Yeah, there's no such thing, but you can check. I just reduced the number of nucleotides. See, there are 38 sequences like this. That's all. So you can check if your experiment worked like that, if that number is low, and if you just wanted to see how many of them has these reads, then you can have these reads. You can actually run this command. Okay, so there's a cheat sheet here. So we put a couple of cheat sheets here. If you don't like this, search yourself. And so there's another thing that you could use, ... So this will do like allow not many, like star means like it could be, the length could be anything. But when you use like this with ... it requires only 3 nucleotides, because sometimes that you put like 21 nucleotide in between these two adapters because you design these oligos and them. And in that case, you can put like, I don't know, like there are other options that you can define like 21, such thing too. This will allow only 21 nucleotides. Or if you want to do only 3, this is going to do the 3 nucleotides. Of course, you need to write. See, these are all like in between these two sequences, there are only 3 nucleotides. The lengths are all the same. Beautiful. So you can do such things with grep. And if you want to exclude them, if you want to exclude some of those sequences and see the rest, you can use -v. For example, in this case, you want to exclude these guys, only include that guys. And then you can run this. These came. So this -v option is excluding these sequences. So you can use the pipe like this to exclude something like, intersection, union, like you can use different mathematical operators to use these commands. In the last 10 minutes, I think I want to show awk. I love awk command. So this is the same thing, like, one-liner. It's hard to learn, but I want you to invest some time. If you learn this, this is #1 thing. If you guys, some of you guys wants to be a bioinformatician, you need to know awk. and VI, like the editor. So these are two cool things, hard, but you can learn, anybody can learn. And why this is good is like, I showed you that our command while trimming, for example, you can write your scripts. But what you need to do, this is just one command, okay, like up. So there are lots of parameters you can use in ALK, but basically you're writing everything here into these commas, and or there's another version Gawk. You can do more things with Gawk. It's GNU ALK, but the capabilities are more. But let's learn ALK. You can do the same things that you do with ALK with Gawk too. Just what you can do, like you can search internet, like I want to get like the total of one column with ALK. If you search such things, you can improve yourself with ALK, but this will make your job much easier. So what you basically do is this. Like grep, you can run ALK to do multiple operations. For example, if you have this ls minus l, like you have 1, 2, 3, 4, 5, 6, 7, 8, 10 columns in this file. I'm just going to put this into ls.txt file. Okay, this is a file now I created, and with this, the output is in here. So what I want to do with ALK, for example, I just want to get only this column, only the sizes. Let me do this with H. It's going to look better. Or any column you want, any file. Imagine like that. So let me show this. See, this is a megabytes and stuff. I have this in this directory and in my ls.txt file. So what I want to do there is, for example, with ALK command, I want to print only this column. Which column is that? 1, 2, 3, 4, 5th column. If I do like this, magically, it's coming here. See that column in my hand now. So, or I want to just get, for example, together with the permissions, I don't know, like, or the users, or the file names, whatever you want to do, together with that. And you want to change something, for example, you want to put like, I want to put permissions here. See, $1 is the first column, $5 was the 5th column. And I want to put like something in between, like this kind of thing. See, so these parts are harder to understand, but once you get it, you're done. So you always write the ALK command in between this dot and this parenthesis. This parenthesis specific, you cannot change the parenthesis, it's built in. ALK understands like that. My commands are coming here, inside, excuse me. So, and the first column is this, and I wanna put something in between these guys. You can put tab character, you can put like dash, 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 you can put anything you want. You can add a new column here, new column. Sorry. Any questions here? But again, like how I'm putting this code. Excuse me, sorry.
上一节课还有很多人上的，
Please,
今天没有什么人上。
can you
第一
please
节课还
mute this? Honor, could you please mute the people? Okay, I'll do it. Okay, so here, so what I'm going to do is like, I want to put something in between. So, but these $1, $5 are the variables that they are used to get the column numbers. Okay, $1, $5. If you just do $0, for example, it will print the whole line $0 because you didn't choose the column. $1 is gonna just do the first column. Okay, so but what I want to do now is I want to add something, a text in between, and then if text or strings needs to be inside of the quotes. Okay, like for example, I'm going to put this and column 1 and column 3. For example, I have the group name in the column 3. See, I'll put dash, dash, dash. If I want to do with my username and the group name and with a dash, oops, sorry. 3 and 4. I forgot the second one. See, I just put like my username, I put dash, and I put the group name. Sometimes, the files that you are using, you want to put the gene name, and in the column 4, you have the one samples expression levels. You just want to exclude the others, and then you can use this. If you want to put a tab character, we are using this escape character. These are called escape characters, and it's going to, but what I'm doing is inside of codes, I merge like $3 and 4 with tab character. You're not going to see that by eye, but this is tab in between here. Okay. That sometimes you're using R, for example, you create your own file and then open it with in R using read.csv command in R. We're going to learn those things and separate them with tab. And then you want to use this information in your code. So these are going to be really important while you're preparing your file manually. Or you want to put an enter character. So this is going to go down there. Or R, it's going to do that. R is going to do this on top of it, and is going to do it not on top of it, but down there. Okay, so you can put them into another file, like, user and group. That takes for everything, So, and sometimes you just want to do this, PS, for example. PS minus, let me show you a very cool thing, PS minus EF. Okay, I want to get which users are here, PS, and it's in the first column. There are many cool usage of this for admins, for example. See, it's just bring me all the users, but there's another cool command, sort. And if you use sort minus U command, for example, this will bring all the users on this node. See, and it's unique users. It's not like putting all these multiple times. It's just printing all the unique users here. And if you just want to see the ones with like from Worcester grep, you can do the grep here. See, these 2 users are there. I'm going to do the same thing. I'm on the node, but if I exit here, and if I'm the head node, like head node, there should be many Worcester users. See, these are all the users. You can tell, and how many users are on the head node now? 64. See, I told you, lots of users are using head node. So that's why you need to respect these people. But again, this awk is very cool thing that with a couple of things I did like this, you can select any column you want, sort them, grep them, and any file. Basically what you need to do this after our command, you need to either write the file name here, or if you don't write the file name, the good thing here is you can send this any command output to awk with pipe that I showed you. And then when you, without writing any file name here, into the third is a third parameter, you can actually send this output to the awk to do the operation. Okay, so it could be anything, by the way, any command. I don't know, like help, for example. This is help command, but I just want to get something about the time. Okay, time. You can do help, grep time. Oh, maybe it's not the right thing. Maybe help, maybe it's not working like that, but let me do this for other help. Like, for example, not every command is working the same. For example, some of them are writing everything to the channel 2. That's why we are seeing this channel 2 came here, means the error. They're writing things error. They don't want me to do grep in the channel 1. But if I do like this, see, brought help the channel 2. How was it? Oh, I don't know. I'm doing something wrong. Yeah, sometimes you forget things when you don't use long time. Yeah, whatever. I can solve that later, but what I'm trying to show you here is just go over all these things now because we are done, and try to solve your problems, try to use the cheat sheets, and try to do this yourself with VI. This is an editor. It's a very cool editor, very hard to use. But if you read here, you can create the files. Maybe I can very fast show you, like test file, for example. You cannot write anything here now when you run VI and a file, but if you press I button, you can start writing things, and you can write your commands here, multiple commands, and then create your file that you want to run in the future, for example. And then if you press escape button, column and WQ exclamation mark, this is always the same. And you can save that file, and you can look at inside what you write in it. See? So this is good. Sometimes you want to change something that, for example, I created a file today. What was the name? Train.dash. For example, I want to change something here. You can come and change, save it, escape, WQ exclamation mark, and then it will save it, and I can run the same thing again and again in the future. But you need that editor to change something. Or you can copy that file into your machine, change with another editor, copy back that you like, and then that might work. But I always use this VI. Or some people are using Emacs, another editor. Just go over this tutorial and read this and apply WQ, WQ, escape, insert, learn these things and do your homework, please. And then next Tuesday, we're going to continue with the genomic resources in our cluster. Okay. And I'll stop recording here. And if anybody wants to ask any question, we can answer. Or you can continue asking them on here on the bootcamp. Okay, guys, thank you. I'll see you next Tuesday.
Thank
Bye.
you very much, Alper. See you next Tuesday.
Thanks. Bye.
Thank you.